Hello, let's do another problem. Section 3.10, number 33. The edge of a cube was found to be 30 centimeters. So we do have a cube and the edge is 30 centimeters. With the possible error in measurement of 0.1 centimeter. So, 0.1 centimeter is possible error. What does that mean? That means that this edge could be as high as 30.1 centimeter or as small as 29.9 centimeter. Use the differentials to estimate the maximum possible error, relative error, and percentage error in computing the volume, and part B, the surface area of the cube. Okay, so what is it that we know about volume of cube? We know that the volume of cube, V equals to x times x times x, or x cubed. And if I take the differential of both sides, well, let's take the derivative of both sides. So I have dv dx equals to 3x to the second. And since differentials, we want the dx on the right-hand side and dx in many applications and situations, the change of x is measurable. So since it's a physical or representing a physical amount, you can pretend like I'm multiplying both sides by dx and saying that dv equals to 3x to the second dx. And that's perfectly fine because the x is measurable, at least in this case, and the dx is given, the possible change of x, which is 0.1. Let me go to the next page. Okay. So going to the next page. So dv equals to, we said 3x squared, so 3 times x is given to us as 30 x squared times dx, which is 0.1. Put that in your calculator and you get 270 centimeter cubed. And that is, what is that? That is the maximum possible error. And so some of you will look at this and you're going to say, wait a minute, for the cube of that size, this is lots of error to have. And that's true. But in real life situation, the maximum possible error almost never happens. It's as if you deliberately wanted, you did everything you could to make that much error, so it is a relative error that usually happens in life. So maximum possible error is 270 centimeter cubed. What is relative error? Let me change color to black, and I have now relative error. What is relative error? Relative error is the ratio or the change, or delta V, the change of volume divided by the theoretical volume, as of if there was, if we lived in a perfect world. So the delta V divided by V will give us the relative error. And so what is it that we know about dV? We already learned that dv was 3x squared dx, and the theoretical volume is x cubed. And if I simplify this, I get 3 times dx over x. And so this equals to 3 times dx is given as 0.1 divided by 30, okay? And that equals to 0.01. And what is this? Is my relative error. Much, much nicer than the previous number, than the maximum possible error. Now, the author of the book is asking for percent error. Percent error. So the percent error is relative error times 100. So that equals to 0.01 times 100, and that equals to 1%. So the relative error is 1%, which is very reasonable. Now we want to do the same thing for the surface area. Okay, for the surface area of this cube. Part B, surface area. What is it that we know? We know that the surface area of a cube is, every cube has 6 sides. So 1, 2, 3, 4 outsides, top and bottom, 6. So I have 6 times x squared is what I know is for the surface area of any cube. So now if I take the derivative of both sides, I have ds dx equals to 12x, and this follows that ds equals to 12x dx. So the first part was derivative. The second part is known as differential, having the dx on the right-hand side. And once again, because many things in this life are measurable, and if there's something is measurable and tangible, let's say 5, 6, 10, it is okay to multiply both sides of an equation by anything that we want. So here I'm going to say that when x equals to 30, and when change of x or dx equals to 0.1, then ds equals to 12 times 30 times 0.1, that equals to 36, okay, centimeter squared, and that is maximum possible error. So as you can see, the maximum possible error usually is a number that you look and you say, whoa, wait a minute, that's lots of error to have. But that's the maximum possible error. In real life, we usually encounter relative possible error. So for relative possible error, okay, I know relative possible error is the ratio of the change of surface area divided by theoretical area. So this equals to, which is approximately equal to ds over s. So this equals to ds, we already know that 12x dx divided by 6x to the second, and that equals to 12 and 6 simplify, so I have dx over x, and so this equals to 2 times 0.1 divided by 30, and that gives me 0.6, no, 0.006666 and on, which is going to be 0.006 repeating. And for the relative error, relative error, all I have to do is multiply that number by 100. So I do have 0.006 with repeating times 100. That equals 0.6 repeating percent. I hope you like this example, and thank you.